Assalamualaikum warahmatullahi wabarakatuh to the honorable lecturer, Mr. Ferry Irawan, and my dearest friends that watch this video. My name is Kurnia Ramadhantio Mycharoka, and today I will make a short presentation about method for prevention and control of spontaneous combustion of coal seam and its application in mining field. There are still a large number of coal fires, even along with the advance of fire extinguishing technologies. Specifically, spontaneous combustion of coal seam has been and continues to be a big problem in coal mines in China, the US, Australia, and Europe. Approximately 25.1% of key coal mines of China are highly gassy mines, which could result in a catastrophic sequel after burning. In recent 10 years, serious incidents happen frequently among them. Most of incidents were related to spontaneous combustions. Coal spontaneous combustion would pose great threat to the safety of the whole mine and all miners, especially when it occurs in or nearby coal mines. Besides, environment of areas surrounding mines during combustion can be threatened where large amount of toxic gases including carbon dioxide, carbon monoxide, sulfur dioxide, and hydrogen sulfide can be released by fire in mine. In China, every year, the amount of coal that was combusted through the coal fires could reach up to 200 million tons, which constitutes almost 1% of the global carbon dioxide emissions. Around the world, 40 tons of mercury were emitted into atmosphere due to a coal fire, while nearly 3% of world's carbon dioxide was estimated to be released from coal fire. Hence, the prevention and protection from coal fires, specifically spontaneous combustion, is of great importance to safe production of mining industry and the global environment. In this paper, spontaneous combustion in coal seam is studied as it can directly affect mining operations. There will be great harm once there is spontaneous combustion in coal seam in mining field, which results from three reasons. 1. Fire will pose considerable harm to the safe production and the lives of mining operators, as there will be lots of workers in mines while coal seams catch fire. Also, mining companies will suffer from coal resource loss in these seams that has been developed. Besides, living conditions for surrounding citizens will also be largely affected. It is meaningful to study the mechanism of prevention against coal seam spontaneous combustion in mining field. Spontaneous combustion of coal seam has been and continues to be a big problem in coal mines. It could pose great threat to the safety of the whole mine and all miners, especially when it occurs in or nearby coal mines. Besides, environment of areas surrounded mines during combustion can be threatened where large amount of toxic gases, including carbon dioxide, carbon monoxide, sulfur dioxide, and hydrogen sulfide, can be released by fire in mine. Hence, it is important and significant for scholars to study the controlling and preventing of the coal seam fire. In this paper, the complicated reasons for the occurrence and development of spontaneous combustion in coal seam are analyzed, and different models under various air leakage situations are built as well. Based on the model and approximately calculation, the difficulty of fire extinguishment in coal seam is pointed out as the difficulty and poor effect to remove the large amount of heat released. Detailed measurements about backfilling and case analysis are also provided on the basis of the recent 10 years practice of controlling spontaneous combustion in coal seams in China. A technical fire prevention and control method has been concluded as 5 steps, including detection, prevention, sealing, injection, and pressure adjustment. However, various backfill materials require different application and environmental factors, so in this paper, analysis and discussion about the fact and engineering application of prevention of spontaneous combustion are provided according to different backfilling technologies and methods. Once the aforementioned fire prevention can be widely applied and regulated in mines, green mining will be achievable concerning mine fire prevention and control. This concludes to this article has analyzed the danger of spontaneous combustion in coal seams and its influence on mining operations. It was pointed that 8.12 kg water will be required at 25 degrees Celsius to extinguish heat produced by combustion of 1 kg coal. Assuming the heat release heat by coal at 20,900 kJ per kilograms, the characters of air leakage from ground to working phase are summarized systematically for the first time. Based on lots of practice and experiments on preventing and controlling coal seam fire in recent years, has application of the basic technologies and some innovative methods, a systematic and complete procedure to control and extinguish the spontaneous combustion of coal seams fire are formatted and proposed as fire steps, including detection, prevention, sealing, injection, and pressure adjustment. Also, different methods are analyzed to be adapted in different situations with exemplifications from practice, including inflation leaking, stopped materials, chemical inhibition foam, pressure adjustment with positive pressure in working area, and their application. These new and systematic methods to prevent and control the spontaneous combustion of mining coal seems have implemented successfully in several coal mining areas in Xinjiang and Shanxi, China. A new regulation and standard concerning prevention and control of coal seam fires can be established on the basis of further study to protect lives of miners and health of workers, as well as effectively protect the environment around coal mines. In addition, some parameters are recommended. The first will be when detecting coal fires, the concentration is detected by manometer every 50 meters longitudinally and latitudinally on the ground. In areas with high concentration of radon, the distance should be shortened to 25 meters. And last, adjust the ventilation facilities to let the static pressures in the area around 50 PA higher than the pressure in the fire area. So, that concludes my presentation. Thank you to our honorable lecturer, Mr. Ferry Irawan, for listening. Thank you too to my friend that have listened to this video. I bid you very well. Assalamualaikum warahmatullahi wabarakatuh.